everybody. Hope you're having a great day. Today we are just going to kind of do some stuff to get us set up for evaluating some limits. Okay, so we're going to take a little pause from officially evaluating limits so that we can review a few key algebra skills. If you are using your notes packet, it is, at least at the time of me making this video, there's a blank page on page 14. Okay, for you to write this down. And the reason why it's blank is because some of these problems take up a little bit of space, and everybody's got their own handwriting, sizes, and so I just wanted to make sure you had space to write each problem. So you may even see me move these up or down. Anyway, we're going to kick things off with what usually looks the most intimidating, and that is the idea of using a conjugate. And so I just want to remind you that, we talk about using a conjugate a lot when we talk about the difference of two squares, which basically the conjugate relates to factors, right? So let's say you have a factor, a minus b, its conjugate is a plus b. Basically, what that means is you could multiply by the missing factor, by the missing conjugate factor, to create a difference of two squares. So here's the deal. If you haven't understood why we use a conjugate, hopefully now maybe this helps. The other thing I want to tell you is that you use the conjugate specifically and you go for a difference of two squares specifically, because a difference of two squares is like the first thing squared minus the second thing squared. And so then you don't have a middle term, all right? And usually you want to get rid of the middle term. Like you're using the conjugate because you got something kind of gross. Note the square root symbol in here. We have something kind of gross. We want to get rid of that. Okay, so here's the deal. We have this square root of some stuff. That's like our A. We have a 5, that's like our B, and we have subtraction in between. So we've got an A minus B situation. So we are going to multiply by A, which is the square root of x squared plus 9, which cannot be reduced because of this addition symbol, plus 5. Okay, in order to do that without breaking all the algebra rules, we have to multiply by x squared plus 9, square root of that, in the denominator as well. So this is just a fancy way of writing 1. Okay, so when we do this, I know, looks really kind of crazy and intimidating. Keep in mind that these are factors. And keep in mind also that we're doing this to make something really nice happen. So I'm going to show you something, and maybe you're going to want to write it down, maybe you don't. This is your call. So you may want to just kind of listen for a second and then jot this down. So first thing I'm going to tell you is I would leave the denominator alone. I would not multiply out the denominator because nothing matches there, so nothing is going to end up canceling out or looking nice. So I'm just going to rewrite my terms in the denominator. Okay, next thing. This is the part where if you want to write this all down, you can. If not, I'm trying to allude to pencil by using gray. So the first thing is that we're going to take, the square root of x squared plus 9, and we're going to multiply it by itself. So that means it's going to be squared. We'll get back to what that might mean in a second. I think hopefully you're thinking about that. Then we distribute the next term, and we get positive 5 times the square root of x squared plus 9. All right, so that's our first term, our A term distributed. Now we distribute B. So we get negative 5 square root of x squared plus 9. And then we distribute the negative 5 again, and we get negative 5 times 5. We get negative 25. Okay. So at this point, hopefully, it maybe looks a little messy, but hopefully you notice something nice. And this is, again, why we use the difference of why we use the conjugate, because the difference of two squares does this. These middle terms cancel. Okay? And maybe taking a little bit of a long time to show you that, but I just want to make sure you don't miss it. Okay. The other really nice thing about using the conjugate with this root situation is that the first term, the square root and the squared, are inverses, so they cross out. So we end up getting x squared plus 9, nothing, minus 25. That's much prettier. in the numerator. And then the denominator still kind of looks a little gross. But don't worry, some nice things are about to happen. Plus 5. Okay. So I do a little math, right? A little simplifying. X squared plus 9 minus 25. 9 minus 25 is... Here, wait, I'm going to pause. This. I'm going to save myself a little step here. That's x squared minus 16. Ooh, 16 is a perfect square. Guess what? That is also a difference of 2 squares. So that's x minus 4 times x plus 4. Oh, wait a minute. Something really awesome is happening because we've got this rational function with, I just made that way too long, folks. So sorry. Okay. So I'm so excited I can't even write. So we have x minus 4 and x plus 4 on the top, and x plus 4 times this junk. So we can cross those out. Okay, now, just a spoiler alert, you need that to happen. Okay, you need that x plus 4 factor to cancel out. Okay, otherwise you are not going to be able to do the limit that we're going to ask you to do in a little bit. So that something needs to cancel in the numerator and denominator when you use the conjugate. Otherwise, you messed something up in the earlier steps. So now this might not look like a super pretty answer, but this is our simplified answer, and you're going to be happy when you get to this spot because then you'll actually be able to evaluate your limit. So yay! I know you may not think that that is simpler, but it is going to remove the discontinuity that is existing within that you're going to have to deal with. Okay, so key thing is using the conjugate when you have a root in order to get the root out of the numerator, which is not helping us, and then to cancel out a factor. So that's the first thing that you learned about today in this video, is using the conjugate. The second thing we're going to talk about today is getting a common denominator. And I say baby denominators because typically the situation is going to be that you're going to be given some sort of, function like this. Like we've got f of x equals 1 over 3 plus x minus a third over x. And I say baby denominators because these are like denominators, fractions within fractions. I keep picking green and it keeps writing in black. I don't know what's going on here. There we go. So this 3 plus x, that's a denominator. 3 is a denominator. They're like little baby ones inside of our fractions, okay? And so as a reminder, to get a common denominator, you need the same, again, in case you have forgotten, you need the same factors. Okay, a lot of times people just want to throw numbers into the denominator, and that's just not true. You need the same factors in there. So right now I have a factor of x plus 3 or 3 plus x. And I have a factor of 3. Those are not the same. Okay, because one of them has an x in it and one of them doesn't. And you can't just multiply by x, because then there'd be 3x instead of x plus 3. So what we have to do here is we have to multiply this fraction on the right by the denominator of the other fraction. And I am going to rewrite it as x plus 3, because that just looks nicer to me. So see, we have a 3 and x plus 3. Those are 2 factors. Now that's going to be in this second fraction. You're going to have negative x plus 3 over 3 times x plus 3. And then I'm going to multiply this fraction on the left by 3, because that is the factor that's in the denominator of our other fraction. So I've got 3 over, again, 3 times x plus 3. And I know this is kind of annoying that the denominator is so small, and that's all over x. Now the purpose, again, of getting a common denominator is so that I can combine the numerators in my, the numerators of my numerator, because I've got these baby fractions with these little denominators. Okay, so I get, when I combine these, I've got 3. And then this negative gets distributed. So I get a negative x and a negative 3. You could have also done that when you wrote this, but then you would have had to switch this to a plus. So it's kind of up to you on when you want to do that. And then we have this over 3 times x plus 3. And then all over x. I usually try to make the main, like this middle guy longer to let me know that that's where like the top and the bottom is, just to help my eye line. Okay, so then, like I said, sometimes these take a little bit of space. I'm going to kind of jump over here on my screen. So it looks like I've got 3 and a negative 3, so that's just 0. So I've got negative x over 3 times x plus 3, and then all over x. Now, at some point, you're going to have to be like, I don't want this fraction within a fraction situation. So the other thing I want to remind you of is that whenever you have a fraction divided by another fraction, let's keep in mind that this is really over 1, you can always keep the first one and then multiply by the reciprocal. So times 1 over x. So here I just took the reciprocal. Now, if you're wondering like why I haven't multiplied this through this denominator, it's because sometimes that's going to cancel. Sometimes, and you can only eliminate a factor if you keep it in factored form. Okay, so that's why I've been doing that. Now we've got a negative 1x and a positive x. Those are going to cancel. That's gone. So then my final answer here, in terms of like rewriting this without the fractions within the fractions, would be negative 1 over. Oh, my negatives are going to cancel. That's nice. Wait. I think I wrote an extra negative. Sorry about that, guys. I was like, I don't think that cancels. All right, negative 1 over 3 times x plus 3. All right. Let me just check my maths. Yeah. All right. Okay, so the last thing should be really the most straightforward thing, because we did this in our rationals unit a ton, and that's factoring. So let's just remind ourselves that we want to treat each piece as sort of its own problem, okay? And I'm going to kind of talk through how I think about factoring. Okay, again, you can use split the middle, you can use a variety of different tools, but at the end of the day, at some point we just need to understand like what's going on here. And so if we're factoring, it's usually because we're seeing something that's quadratic. Okay, and if we're seeing something quadratic, we know we have 2 sets of parentheses because we've got an x times an x, and that's how we get our x squared. That's normally leading the function. And so that's exactly what I think about. I think about just dropping an x at the beginning of each factor, and then I ask myself, I think in my head, okay, I've got a negative 9. Well, how can I multiply to negative 9? I think about all the ways that can happen. So notice I'm thinking about multiplying. And then I think about, oh wait, in this one, there's nothing in the middle. So is there like a particular combination of numbers that would give me 0 in the middle? In this case, I'm thinking negative 3 and positive 3. Because negative times a positive is going to give me a negative number. 3 times 3 is 9, and negative 3 plus 3 is 0. Okay. Most of us have done a pretty good job when the leading term is 1. When the leading term is not 1, this is when we get a little bit funky. Some of us have done some weird math with this. So let's keep in mind, again, the leading term. The first 2 things you write down have to multiply to that. Our only way to multiply to 2 is 2 times 1. The only way to multiply to get x is x times x. And then the only way to multiply to 3, we got 1 times 3 or 3 times 1. Okay? And it's positive, and the middle's positive. So everything's going to be a plus. That's guaranteed. So then I think, okay, well, I could put, I'm going to write with like my little gray here. I could do 2x plus 1 and x plus 3. Or I could do 2x plus 3 and x plus 1. And I just have to figure out, like, which one's going to get me 7, right? I need a bigger number than 2 and 3. So 2 times 1, that's going to be 2. 3 times 1, that's going to be 5. That's not going to work. So then 2x plus 1, that means the 2 and the 3 when we multiply together, that'll be 6 plus 1x. That's going to give me 7. So that's what I want. I want 2x plus 1, and I want x plus 3. So you just got to kind of play around with it. Okay, and so then we're factoring because there was probably some sort of issue when we tried to plug in a value, and we had to cancel that discontinuity out, and then we are left with the factors remaining after